everyone, today we are going to discuss about our chapter chemical reaction and equations. So content of this chapters are physical and chemical change, second chemical equation, balancing and its type, characteristics of chemical equation, chemical reaction and its type, oxidizing and reducing agent, oxidation in daily life. Then we will discuss about some questions of NCERT, MCQs and then hot question. So in today's lecture, we will discuss about these first 2 points, that is physical and the chemical change, chemical equation, balancing and its types. Okay, so first of all, we have physical and chemical change. The changes that takes place in substance may be categorized in 2 classes. The first one is physical change, that is in which there is no production of any new substance, only a change in the physical state or physical outlook changing is there. For example, crushing of a can, phase change during melting of ice. For example, if ice is melting, ice is a solid form of water, so it melts into liquid, that is what phase change. You can see this crushing of paper is what phase change, or you can say it is a physical change. Crushing of can, melting of an ice, boiling water, mixing of sand, breaking glass, dissolving sugar in water, shredding of paper, chopping of wood, all these are the physical changes. Now we will discuss about the chemical changes. In chemical changes, we have a new substance. In chemical changes, some substances react, or there may be a division of one substance to form 2 or more new substances, and in this the new substance which is produced is totally of different property than that of their reactant or the from which it is produced. Example: burning, rusting, photosynthesis. We will discuss about the further examples. Further examples are rusting of iron, burning wood, metabolism, the digestion of our food, cooking of egg. In cooking of egg, there is denaturization of protein, baking of cake, rotting of banana, electroplating, vinegar and baking soda mixture, fireworks, battery, chemical battery. These all are the examples of chemical changes. Now we will discuss about difference between physical and chemical change. The first difference is the definition itself, that is, no new substance is formed in the physical change, but in the case of chemical change, there is a new substance formation. Second point, physical change is temporary change, but a chemical change is a permanent change. So from this temporary word, we can also spell it like that, or we can also say it like that: physical change is reversible, that is, we can reverse the physical change. For example, if ice is there, we can melt it to form water, and water we can again form ice by cooling it. But chemical changes are irreversible. Once it is formed, we cannot reverse a change. In case of physical change, a very little amount of heat or light energy is usually absorbed or given out during a physical change. But in case of chemical change, there is a lot of amount of heat and light may be absorbed or given out. It depends. Sometimes it is very high amount of heat and light energy, sometimes only heat energy, sometimes only light energy. It depends upon the type of chemical reaction. Okay, now question time. So predict the chemical and the physical change from the picture. So first picture, breaking of glass. Correct, this is a physical change. Freezing of popsicle ice. Again, it is a physical change. Spoiling of milk. Milk becomes sour when it is not kept in the freezer. That is a chemical change. That is curding of milk. Slicing of bread. It is again a physical change. Roasting of marshmallow. Roasting means heating something in the presence of oxygen or in the presence of air. That is what this is a chemical change. Breaking of egg. It is a physical change. Exploding fireworks, we have discussed it, it is a chemical change. So these all will be your homework, you can do as a homework. Okay, now second question, which change is temporary? Yes, physical change is temporary. Third question, Which change produce new substance? You are correct. That is, chemical change produce a new substance. Fourth question. Give examples of changes in which there is a both chemical and physical change. For your hint, I am giving you one example, that is burning of wax. So burning of wax is both, that is physical change, wax is melting, wax melts, and again wax is you can say react with oxygen and forms carbon dioxide and water. So I want two other further examples of such. Okay, now the fifth question, which is an MCQ question. Nowadays these MCQs are the part of your examination. So fifth question, when ice is heated it changes to water, and water is further heating gets converted to steam. What happens when steam is condensed? I'm again repeating the question. When ice is heated, it changes to water. Ice is changing to water, it is a physical change. That is, it is melting. And further, water on further heating gets converted into steam. So water is converting into steam, that is again a physical change. So what happens when the steam is condensed? Steam is condensing back into the liquid, that is into water. So it means it is also a physical change. Now looking towards the option, as this is a physical change, so there will be no new substance formation. So option A is incorrect, that is wrong. Option B, no new substances formed, that is correct. Gaseous phase changes to liquid phase, this is also correct. So both B and C are correct option. So we can say that option D is correct as it contains both B and C are correct. So for this MCQ, the answer is option D. Is it clear? Okay. Moving further, we have chemical substance. A chemical substance is a form of matter that has constant chemical composition and characteristic property. For example, if we say water, water means H2O. The formula or the constituents of water remain constant. Copper sulfate, that is CuSO4, that is copper sulfate will always contain copper, sulfur and oxygen, and characteristic property, that is it is blue in color. So each and every chemical substance has a constant composition and characteristic property. So what we call it as a chemical substance. Then chemical equation. So the way of representing any chemical reaction with the help of symbols and some arrows on a piece of paper is known as chemical equation. So for our exam purpose, the definition what you need to write in your exam will be: a chemical equation is the symbolic representation of a chemical reaction where the reactant entities, the reactant means which are going to react, are given on left hand side, that is left hand side, and the product is given on the right hand side. So the form of chemical equation, here we have H2 plus O2 gives you twice H2O. In this 2 and this 2, these are known as stoichiometric coefficients, and these refers towards the number of moles of particular substance. For example, here we have 2 moles of H2 hydrogen gas are reacting with 1 mole of oxygen to produce 2 moles of water. So these two are what? Stoichiometric coefficient. On the left hand side we have reactants, on the right hand side we have product. A chemical reaction describes what happens in a chemical reaction. A chemical equation is nothing but the representation of your chemical reaction. Just for your knowledge, the first chemical equation was diagrammed by Jean Belgian in 1615. Now, types of chemical equation. The first equation is word equation. As from the name, it is clear, in this equation we do not use any symbols. We use only words to describe a chemical reaction. For example, hydrogen and oxygen reacts to form water. Carbon and oxygen reacts to form carbon dioxide. Sodium plus chlorine gives you sodium chloride. So there is only use of words to describe a particular chemical reaction. We are not using any symbols. So these type of reaction are known as word equation. The problem with these equations is that you can say it covers a lot of paper and it requires a lot of time to write each and everything. For example, hydrogen reacts with oxygen. So this requires a lot of time. And this arrow is a separation between the reactant and the product. Okay, now skeletal equation. Skeleton is a equation is a little bit of improved version of the previous one, that is a word equation. In this, we use formulas and chemical symbols to indicate the chemicals, that is reactant and the product. For example, the skeletal equation for the electrolysis of water is H2O, that is water. Whenever it is electrolysis, that it breaks down with the help of electricity, it converts into H2 and O2. Now, in this equation, this is not a balanced one, where balanced means that is the reactant quantity or the elements on the reactant side should be equal to the product side. So this is not in this equation. So this is known as what? Skeletal equation. So the difference between the skeletal and the word equation is that word equation there is no symbol, but in case of skeletal equation we use symbols to represent a chemical reaction. The similarity between skeletal and word equation is both the reactions or both the way of representing an equation is not balanced. Okay. Now we have balanced chemical equation. A balanced chemical equation is that in which the number of atoms involved in the reactant side is equal to the number of atoms on the product side. It is based on the law of conservation of mass, that is, mass can never be created nor be destroyed and it will remain conserved. So a balanced chemical equation for electrolysis of water is twice H2O, that is, two molecules of H2O combines with two molecules of H2 plus O2. Now, how to read a balanced chemical equation? Students, this is a very important thing, that how we can read a balanced chemical equation. And for better understanding, I always recommend that please prepare your notes. You can pause the video, prepare your notes, write down each and everything on your copy, then it will be beneficial for you. So, for example, this equation, CH4, we all know that CH4 is methane, O2 is oxygen. So we can say that this is the combustion of methane which is going to produce CO2 and water, that is carbon dioxide and water. So we can read this equation. This equation would be read as CH4 plus 2H2O yields, this arrow means yield, carbon monoxide, that is CO2 and carbon dioxide and H2O. Using the IUPAC nomenclature, this equation would be read as methane plus oxygen yields carbon dioxide and water. The stoichiometric coefficient, that is this 2 and this 2 are what? Stoichiometric coefficient. Numbers in the front of the chemical formula result from the law of conservation of mass, that is, this equation is the balanced one. Now, what is the need to balance a chemical equation? A chemical equation is balanced in order to satisfy law of conservation of mass. I have already told you, it states that matter can neither be created nor be destroyed. Now, what is the main purpose of balancing an equation? This is not just to satisfy the law of conservation of mass. The main purpose is, from this particular balancing the equation, we got a quantitative information about the reactants and the product. By the quantitative information means we can get the amount of what amount of reactant is suitable to react so that it will produce that particular amount of product. For example, you have a ammonia factory and you got an order to produce 30 kgs of ammonia. So you should know what amount of nitrogen and hydrogen are going to react with each other so that you can produce 30 kg of ammonia. So this gives you about the quantitative information. Now the most last topic for the day is how to balance a chemical equation. For example, we have HCl plus NaOH gives you NaCl plus H2O. In this equation, hydrogen 1 and 2 hydrogen 2, chlorine 1, 1, sodium 1 and oxygen 1. So 2 hydrogen is 2, chlorine 1, sodium 1, oxygen 1. So they are on the left hand side, that is on the reactant side. On the right hand side, each and everything is same. So this is a balanced chemical equation, automatically balanced chemical equation. We do not need to write any of the stoichiometric coefficient. Now this one, H2 plus O2 gives you H2O. This is not the balanced one. Here we have 2H, 2 oxygen and 2H2 and only 1 oxygen. So we can just, in order to balance this equation, we can just write 2 on H2O. So now it will have 4H and twice O. 4H and twice O. You can clearly see H2O2, H4 and O2. So now in this case hydrogens are less than that of the product. So what we do? We just add 2 there. So now this hydrogen is 4, this is 2, this is again 4. So this is what? A balanced chemical equation. We can take for another example. Copper plus AgNO3 gives you copper nitrate plus silver. So we have only 1 copper, 1 silver, nitrate, nitrogen 1, oxygen 3. Then we have copper 1, nitrogen 1 or Ag1, nitrogen 2. This is 2 nitrogen and 6 oxygen. So just balancing the equation, what we will get copper plus twice AgNO3 gives you copper nitrate plus twice Ag. So this 2 and these 2 are what? Stoichiometric coefficient which we add in order to balance a chemical equation. Now try to solve these questions as a part of your classwork. First of all, try to solve second, third, fourth and then move towards the first one. First one is little bit difficult. If you are able to do 2, 3 and 4 less than 5 minutes, then it will be easy for you to do the first one. I will give the answer of each and every at a time. You can just pause your video and check out the answer. Okay, now this is 8, 2, 3, 4, 2, 2, 2, 2, 2. So this is what? The balanced chemical equation. So for today's class, this is the chapter. First 2 topics. In the next class, we will discuss about the different type of chemical. We will discuss about the definition of chemical reaction and different type of chemical reaction and discuss some questions. So for your homework, remember to do from 5th to 11th. Okay, take care. Bye.